Did you know that volcanic eruptions cause $1 billion in property damage every year? It's also estimated that 40,000 homes have been destroyed by volcanic eruptions. Volcanic eruption insurance typically is not covered, but if it is covered, then you have to trust that the insurance company will hold up your claim. However, with smart contracts, we can have truth and fairness in financial agreements. Chainlink can request JSON API data for smart contracts securely. Job data types handle UN for integers, int for signed integers, and bytes32 for strings. Enabling Chainlink API requests on Ethereum smart contracts gives us the ability to create hybrid smart contracts like Disruptive Insurance. Chainlink API requests are able to get present time data from Time API and volcanic eruption data from OpenDataSoft's significant volcanic eruption database on Ethereum smart contracts.
We use the MetaMask web browser extension and the Infura node to connect users to our dApp securely. Our frontend is built using React, Bootstrap, and the web3.js library. We also use Fleek, which enables IPFS+Filecoin decentralized site hosting.
We compare dates by compressing year, month, and day into a single data type based on priority. Year has the highest bit priority, while day has the lowest bit priority. We use shift left to move the bit rangers and take a sum of all transform values along with the original day value for compression. To get present time on chain, we need to have at least 0.03 link in the smart contract's address. To get data about a specific volcanic eruption, we must specify the time and country of the eruption. Also, we need to have at least 0.05 link in the smart contract's address. Chainlink API oracles send data 30 seconds after a request. Hard hat integration testing confirmed that our requested data was getting put on-chain correctly. This is critical, for the oracle must have its job ID, oracle address, a JSON URL, and a correct JSON path to work properly. The buyer logic flowchart shows how the smart contract allows buyers to buy policies and to claim rewards from their policies that are valid. We unit tested buyer logic with hard hat.
On this slide, we have a logic flow for the 4 contract owner related functions in the contract. These allow the owner to seed ETH to the contract for use in policy payouts, reclaim ETH not yet locked to policies, claim ETH from expired contracts, and claim ETH from self-destruct attacks. Here you can see we were able to achieve 100% unit test coverage on the contract owner related functions.
To buy a policy, step 1. On the oracle page, get present time. Step 2. Policy purchase records address, present time, input coordinates, and locked owner ETH for policy. To claim a reward from a qualified policy, step 1. On the oracle page, get filtered volcano eruption data, time, and coordinates. With this button, we can easily view filtered JSON URL volcano data. Country names with a space must have a plus sign in their filter input. Step 2. Check if policy is older than eruption date and the coordinates are within plus or minus 1 coordinate point. Step 3. In hard hat testing, policyholder claims ETH. If step 2 checks are true, then deletes policy data. Note, we cannot go back in time to sign a policy before an eruption to make it qualify for a claim, but we can test this in hard hat. To attract buyers, add 1 ETH to the contract so that a new policy can be bought. Owners get paid directly after a policy is bought. There are other ways to claim ETH as well. To claim ETH not tied to a policy, step 1. Check if open ETH to insure is greater than 0. Step 2. Claim 1 ETH from the contract. To claim an expired policy, step 1. On the oracle page, get present time. Step 2. Check if the policy connected to a mapped address is over 1 year old. Step 3. In hard hat testing, owner gets to claim the ETH from the policy and delete the policy data. Note, we do this in hard hat because we cannot fast forward 1 year to claim self-destructed ETH. If the sum of accounts insured and open ETH to insure is greater than the smart contract ETH balance, then a self-destruct attack occurred and you can claim that ETH. Even during a GitHub outage, our site is still online because of IPFS and Filecoin.